So yesterday we finished up with tree functions, right? Just setting up the ratio of the sides. Opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent, right? And then we did the reciprocal functions of them as well. Secant, cosecant, and cotangent. All right, you had what, 20 problems? You had 20 problems on that? All right, so, and then we got into unit circle. And we got the first quarter of it, and I said, hey, rest of it, fill it in, look it up, fill it in. It's on Google Classroom. The filled out version is up there. Okay? So if y'all would check Google Classroom, because when I post something every day, guess what you get? You get an email that says, hey, Palmer put something in Google Classroom for you, right? Yeah. You might want to go see all the resources that are there, ladies and gentlemen. There are a plethora of stuff there to make you successful. You just got to take time out of your day to go do it. Okay? So I encourage you to do that. Now, today's lesson is going to go, and you're going to evaluate tree functions with degrees and with radians. And the key to this is a unit circle. Okay? Key to this is unit circle. So what I'm going to do is I'm going to draw a radius. Okay. Now, on the unit circle, we had coordinates of 1, 0, 0, 1, negative 1, 0, 0, negative 1, right? With basically unit circle being a unit of 1, a radius of 1, right? So we're going to play off of that. We're going to show you how some of this stuff comes to fruition. Man. There. So that is 1, 0, right? So this right here is length 1. That radius is length 1. Y'all agree with that? Okay. Now, if I turn around and I put theta right here, this is theta, and if I draw coming down and make a right triangle, then we're going to write what the tree functions would be off that. Okay. Now, okay. What would the sine of theta be? What would the sine of theta be? Huh? Okay. The sine is what? What are we looking for when we find the sine? Opposite over what? Okay, well, we've got the hypotenuse, right? We know that it is what? 1, right? Okay, so what is the opposite? What is this side right here? It is some y, right? Some y value, right? Because it's height, and y's are measured in height, right? Some y value. So, fair enough? So basically what we're going to do is we're going to say that the sine of theta is equal to, guess who? Y. Now, if I want cosine of theta, that would be, what's the relationship for cosine of theta? Huh? It's adjacent over what? Hypotenuse. And for this, it would be what? X over what? So we can say that the cosine of theta is equal to what? X. Fair enough? Now, what would the tangent be? What would the tangent of theta be? It'd be Y over what? X, right? Y'all agree? Ladies and gentlemen, what does Y and X refer to? Huh? No. Look back at this. What does the Y and the X refer back to? It's right there in front of me. Come on. It's got an equal sign. Sine of theta is equal to y, right? The cosine of theta is equal to who? X. So if we say that the tangent is equal to y over x, then what is really the tangent? What? Sine of theta over who? Cosine of theta. Question. Every bit of this right here, you need to make sure you have any notes. Because that right there is everywhere that we're going today. This is how we're going to know exactly what is what. Okay? So you get that copy down now. And I'm going to do. Okay. So y'all understand. All homework this week needs to be turned in on Friday before you take the quiz. Answers up on Google Classroom. No work, no credit. Because you can just copy answers. That doesn't mean you know it, right? So no work, no credit. I will randomly pick ones out of there to grade. Any questions about that? Anybody? So here's the unit circle, right? Look at the ordered pairs. The ordered pairs are in what form? X comma what? Y. Who is the X? Who's the Y? Come on. Who's the X? Who's the Y, guys? Look. Okay? Whatever theta is, and you're going to be given theta, the x value would be the cosine of that, right? The y value would be the what? Sine. So if we were to look here on this, and I said, hey guys, what is the cosine of pi over 3? What is the cosine of pi over 3? I need an exact value. What would you say? If I said, what is the cosine of pi over 3? I want an exact value. What would you say? Not 1/2. Nope. Because the cosine, you're on the right track. No, you're really on the right track. But cosine is whose value? Whose coordinates? Whose coordinate is the cosine? Here, let me do this. Do you see this? The x coordinate is the whose value? Everybody say it. X coordinate is whose? Y's coordinates is whose? It's that simple. It's really that simple. And if I want the tangent, guys, it's the what? Here, let's do this. Tangent would be who? The y over who? X. The tangent of theta. Whatever theta is, right? It could be pi over 3, pi over 4, it could be pi over 2. Could be in degrees, right? It could be whatever. I could give it to you in degrees or radians. It doesn't really matter. These are the ones that we're looking at. You understand? Yes? Okay, for the tangent, you have to put the y coordinate over the x coordinate, and then you have to simplify. Because we can't have radicals left in the denominator, right? We have to rationalize. Any questions on that? Everybody clear on where we're headed? Yes or no? Good, let's go. What is the cosine of pi over 3? Come on, you got a sheet sitting right in front of you, got this up the board. Let's go, folks. Power 3, let's go. You did say 1/2, did you not? Yes, you were right. I was looking at power 6. My bad. You were right. I was looking at this one. I saw the 30 and had the 3 in my mind. You're right. So cosine of power 3 is 1/2. What would the sine of power 3 be? What is it? It's that simple. Do you understand? What if I said, what is the sine of 45 degrees? What is the exact value of the sine of 45 degrees? It's what? Yeah. So you live and die by the unit circle. Do you understand? You live and die by this. Okay? You have to know this. After I quiz you over this, you get to use this. Except for the part of the test. Does that make sense? There's one part you can't use that. Okay? So, I need you to look at the unit circle and see if you can come up with a pattern. Not that I know. I don't know. All right. Y'all ready? Here we go. What is the pattern? What's the pattern? Okay. I want you to look at something. Look. 1, 2, 3, 1, 2, 3. X's started out with 1, 2, 3. That was the right from the top, right? 1, 2, 3. Look at the X's here. 1, 2, 3, 1, 2, 3, right? Okay. But the X's on the left-hand side are negative. Why? Nope. Nope. Look at the coordinate plane, folks. Look at the X values on the coordinate plane. You're in quadrant number 2. What are the signs for X on quadrant of number 2? Negative. So therefore, what? The X values have to be negative, right? Yes? Okay, now, let's look at the lower half, quadrant 3 and quadrant 4. Let's see how those are laid out. The X values don't go 1, 2, 3, they go what? 3, 2, 1, and then what? 3, 2, 1, 3, 2, 1, right? Right? Do you see that? On both the third and fourth quadrant. Any questions on that? All of the numerators have square roots. All the numerators have square roots except for 1. Why? Jay, what is it, bud? Say it loud and proud. The square root of 1 is 1. Right? So that's why I didn't have a square root on it. It's perfect square, right? So therefore everything else is going to have a, and look at the, look at the denominators. What are the denominators on all of these? Yep. They sure. Now, you want to know why? Y'all ready? This is pretty cool. Because this right here is a whole lot of mathematical theory that will blow your mind right there. That's why the unit circle works right there. That's why the X value is cosine and the Y value is sine right there. Here's the other. Why were the values like square root 2 of 2? 1 over 2. Monday, we did a little thing called, let's see. Special right triangles, right? Did we not? Okay, so we discovered or we wrote relationships, did we not? Yeah, it's like short leg, long legs, and legs, hypotenuse, all that stuff, right? So we put this like this would be 1, that'd be 2, and that'd be what? Square root of 3, right? Correct? Y'all ready? This is cool. This is really cool. Here's hypotenuse, right? And it's on this one, I'm gonna do them in green, right? So we got square root of 2, and there's 1, right? You good? Okay, now, if I were to say, what is the cosine of, not theta, but let's just 60. What sides would you tell me? Huh? What is it? Is that, yeah? 1 over what? Y'all agree? Everybody agree? Okay, so let's go look at that. Cosine 60 degrees, right? And that's degrees, right? So let's see. That would be the x value, right? Ba-da-da-da-da-da. Look at that. 1 over what? 2. What is the sine of 60 degrees? That would be, if I'm holding this angle, I would be looking at some old hippie, OH, right? Opposite over what? The square root of 3 over what? Hey, guys. Look at that. So everything that we've done this week, has been pieces to a puzzle that make the unit circle. You understand? See, today's Wednesday, right? And sometimes you're on this journey. We're on this journey, and you're like, what are we going to do today? Woohoo! And then you go like, well, how'd that fit into that? Know that everything that we are doing has a purpose and a reason. One might not see the purpose or the reason yet, but there is, right? Now, do you understand why we looked at special right triangles? Yeah. Now, do you understand why we looked at yesterday the ratio of the sides? Yep. Now, how am I going to tell if what is positive and what is negative in the quadrants? Right? How am I going to tell? Well, let me do this. Let me go back to this one. Okay? Quadrant 1, quadrant what? 2, quadrant 3. Woo! Run away. 3 and quadrant what? Now, question. If you ever forget how the quadrants go, who or what is the name of that? What is the name of this coordinate plane right here? There's a big mathematical word for it. It's just coordinate plane, Miss Mom. No. Cartesian plane. Y'all ain't never heard that? No. Never heard that. Never. Like a bird. No. René Descartes. René Descartes. He was a French philosopher. I think, therefore I am. That is René Descartes. He was not only a French philosopher, he was a mathematician. Yeah. And he is the father of 2D. That little joker took 2 number lines, put them together, and said, voila. Yeah, 2. And put them together right there at 0, 0. And he made 2 dimensions. Because before that, everything was 1 dimension. That's pretty cool right there. Think about what all that old, man, you could scale stuff. You could, a whole lot of math was developed off that, right? That's crazy. Why is it called 2 dimensions? and a what? Two quarters, right? It's crazy. So here's what this cat done. Look, now I can't make this up. This guy right here, you know, he's all dead. He was born in 1700s. Watch this. This is crazy. What's that? How are the quadrants numbered? No, babe. Do you see how you number them? Okay, this is 1700s. This is when people took a shower about once every, I don't know, half a year, 6 months. They had no teeth in their head because they all rotted out. You know, oral hygiene was not a thing back then. No, they didn't have teeth in their head, most of them. Anyway, but so the stuff that they did, they tried to keep it simple. They used KISS method, right? Keep it simple. 2. This is labeled in a C, Cartesian plane at him. Ordered pairs. Why do you think they call them ordered pairs? They're in order per the alphabet. X, then what? That's it. So a lot of these things are not complex, but that's why they're there. Now, here's the thing that's going to make you successful when it comes to trig functions and knowing which ones are positive and which ones are negative. Because if you look right here, we got them right up there at the top, right? Like all of them in the first quadrant, right? Like some of them in the second, some of them in the third, and some of them in the fourth, right? Now, how the heck you going to remember that? So let me show you. Ready? I can't. Okay, let me get to a really cool color. Yeah, let's do purple. All students take calculus. All students take calculus. So I would write the ATSC, or ASTC. Now I'd write that down in my notes. Here's why. Who does it say is positive in the second quadrant? Who did it say? The sign. All students, sign, take tangent calculus, cosine. Cosine in its reciprocal, right? Which would be secant, SEC, go basic, yeah, right? Y'all with me? Yes? We just dissected this unit circle. We just blew it up, right? So, let's go. Huh? Let's go straight to number. You ready to go straight to number 1? Yeah. You ready for this? Man, and it's great. Let's go here. Where are we at? Let's see. Trig functions, right? Yeah, for sure. Yeah. We'll cover that up. Yeah, wait. Yeah. Oh my gosh, we don't want that. What? Yep. All right, so let's go here. I need you to give me the exact value of negative 315. The exact value of negative 315. The sign of it, right? Give me the sign of theta. Theta is negative 315, right? Yeah, give me, go. You got, I don't know, 30 seconds. Bye. All right, you ready? You ready for this? What is the sign? Ooh, I'm sorry. What is the reference angle on said diagram? What is the reference angle on said diagram? Because I hate looking at negative 315. I hate it. What would it be?
So when we have to change the sign
yeah, hello. Yeah, that's why we gave you those sign things, right? Yeah. Okay. Who's like, okay, raise your hand if you're like terribly confused. Like, it's a bad night, Mariposa. What's happening? All right. Okay. Ready? Do you see a 315 on there?
Yeah.
You did?
Yeah.
On your sheet. You see a 315?
Yeah.
But it's a negative 315, right? which means that this baby's sitting in the first quadrant, right? Hey, negative 315 is the same as what? Uh-oh. It's the same as who? Come on. That right there is really 45 degrees, right?
Yeah.
What? No. Yes, it is. Yes, it is. Because look at where we want. We're wanting right here, right? Yes or no? So the sign of negative 315 is the same as sign of who? 45. So what would that be? It would be the square root of 2 over what? Thank you. It would be negative y. No, what quadrant is it in? And who's positive in first quadrant? Yes, I did. Boom! Yep, done it all.
Can you do the clock one? No.
What? Can you do that? Alright. Do y'all see how we got there? Anybody confused about how we got there? Yes.
I got the right answer, but I didn't.
Hey, come around, let's pay attention.
Where did you get 45 from?
Well, on the quiz Friday, we had reference angles. The reference angles are the angles from that angle back to, or that ray back to the x-axis. Reference angles are always positive. Did you hear what I just said? Reference angles are always what? We had a lot of negative reference angles. All right, y'all ready? Any questions? So if we do number 1, which one y'all want to do now? Number what? No, let's do number 2. Let's go in order, and then we'll jump around from there. Right? Hey, it's find the exact value, right? When it says find the exact value, then we're actually looking at unit circle, right? We're going off the 30, 60, 90, 45, 45, 90 triangles, right? Okay, so number 2. There. Oh my bejeebies.
I know it.
All right, I'm gonna give you 45 seconds on this. You ready? 45? Go. Okay. Number 2. What is this tangent of negative 45?
-1.
Huh? Oh, you say? Negative? You sure? You positive?
Yeah.
Who else with it? Yeah, y'all just like, I'm on that one. Yeah, -1. Yeah, all right. I'm talking about. Okay. Look at your unit circle. Do you have negative angles? Do you have? Hey, right here. Helen Kellers, let's go. Right here. Hey, right here. Let's go. Do you have negative angles on that unit circle? No. You do not have negative angles. So what do you think we ought to be working in terms of? If I have a negative 45 degree, what is that? What is another name of an angle that would be the same as negative 45? How much? Positive 315, right? Negative 45 and positive 315, right? So look on your unit circle at 315, right? Tell me the ordered pair at 315. Comma, what?
-2. Negative square root of 2. Other way. Put the square root.
Oh, my bad. Oh, this, right? That's what you say? Yes or no? Okay. What did I say tangent was? What did you hear me say right now? What is it? Ah, love it. So the tangent of the theta is what? Y over what? Right? Y'all with me? So negative square root of 2 over 2 divided by square root of 2 over 2. Ladies, what is anything over itself? 1. And this just happens to be what? I know. Well, I didn't say you weren't. I didn't say you were wrong. I just didn't say you were right. Why do you think I didn't say you were right off the bat? No, because the moment that I say you're right, guess what happens to the rest of these folks in here's brain? Then, see, if I start questioning your answer, guess what it does to them? See, they're going to choose a side, right? So it's all about the thinking, right? And all about thinking. All right, any questions? Okay, these are degrees. So what we're going to do today is all degree. You got 20 problems, right? 20 problems. And they're all degrees. Guess what tomorrow is?
I'm not coming tomorrow.
You're not? You're missing tomorrow? Oh.
Can I get a band-aid?
Okay, ladies and gentlemen, you got number 5. We're going to give you 45 seconds. 4 or 5 seconds for number 5. Go. All right. So, what do y'all say this is? What is the tangent? Okay, first off, do we have tangent written on here? Anybody? Well, we do, but it's kind of taken apart, right? Okay. Tangent of theta is who? What's the tangent of theta? It's who? Y over is sine over what? Cosine. Sine over cosine. So it's y over x, right? So y over x. Give me the y value of 150 degrees. What?
1/2.
1 over 2.
And then negative 3 squared over 2.
Whoa. No, ma'am. Say that again. Negative 3 squared over 2? No, that's not true.
Negative 3
It would be the negative square root of 3 over 2.
What did I say?
Negative square. Yeah.
Hey, look over here.
That's okay. Listen. Okay. Now, what would you do if I took the calculator away from you? Could you do this? Oh, don't cry about it. Come on now. It's 1/2 divided by the negative square root of 3 over 2. Y'all remember this? What is this? Keep, change. Uh-oh. Didn't do that. I just, sorry. Right? So that would be negative 2 over 2 square roots of 3. And you know what we got to do, right? We got to rationalize it, right? Yeah? Right here, right? So that would be, that's negative 2 square root of 3 over 6, right? And that would just be negative square root of 3 over what? 3. Negative square root of 3 over 3, right? Yes? Is that what you got? Is that what your calculator told you? You got that too? All right. Would I, listen, it would warm my heart that you could do that right there by hand. You know why? Because that's 3rd grade skills. On a 9th grade standard. That's 1st grade. Okay. Y'all want to do another? Which one y'all want to do? What? Okay, 17, I like going up in them numbers too. Let's go, I don't know, you pick, choose. 17, 18, go girl. Which one? All right. Augustine, you good on this or you got a question? Augustine, look, you want this green, bro. You want the green. 1/2 over negative 302. Yeah? Okay. Listen. Today is Wednesday. Better known as Wednesday. Hump day. Anything from today forward is subject to have a pop quiz on the unit circle. I will hand you a blank unit circle, and you have to fill it out completely. So from today on, any time that I see or deem necessary, I can still, okay, clear your desk. Unit circle, go. So what do you got to make sure you know? Have I shown you how to fill it out? Yes, I have. It's the 1, 2, 3, 3, 2, 1, or 3, 2, 1, 1, 2, 1. You got to know which one things are, right? Then you got to know your 36 and 90, right? All of your 30, 45, 60, 90, all that round, right? All in their things, right? Yeah? All right, so y'all working this problem. Let's go.